and gentlemen. Today we will explain about our recent research entitled Application of 3D Reconstruction System based on close-range photogrammetry method for crow estimation of Chinese cabbage, Brassica pekinensis L. Before starting to the material, let me introduce our team. 3D plan team from Gadjah Mada University consists of Ardian Widianto Putro, Rivaldi Albian, and Pratnya Umaradani. We were guided by Andri Prima Nugroho, PhD, and Professor Lili Setiarso. Okay, first let's talk about introduction. Indonesia is a country with 1/8 of its land area used as agricultural land, and 38.2 million people work in the agricultural sector. But production of agricultural products in Indonesia is still not optimal. Several factors that influence this problem are the massive increase in population, the decreasing number of workers in the agricultural sector from year to year, the conversion of agricultural land, and the lack of technology utilization. Therefore, we need solution in overcoming the problem of agricultural productivity, one of which is precision agriculture. What about precision agriculture? According to Yos et al. 2019, precision agriculture is a conception of a chain of information and is focused on producing direct benefit to the environment. Plant measurement is one of the fundamental processes in terms of application of precision agriculture. They are necessary to observe the rate of growth and improve agricultural production system. One of the easiest ways to check plant measurement is to separate the part of the plant that will be measured by the main body, or commonly referred to as destructive measurement. In a study conducted by Russell et al. 2009, it was suggested that destructive measurement of plant by damaging part of the plant was more detrimental than non-destructive measurement that were shown to provide more data in a single. The close-range photogrammetry, or CRP, is one of the solutions in non-destructive measurement of plant by utilizing digital image of object, and has low risk with non-contact measurement. However, to present the functionality of the system for plant growth behavior, it is necessary to evaluate its accuracy and performance. Then, the objective of this study. The objective of this study was to apply a 3D reconstruction system using CRP method for validating volume variation and estimate the rate of growth of Chinese cabbage.
Okay, let's continue to materials and method.
This is the research framework. The camera will carry out the process of acquiring video of plant objects in 360 degrees rotation with two different angles. And then, the video obtained will be processed on the software to get the form of plant predictions. This research was conducted in January to July 2021 at Smart Agriculture Research Group, Agroinformatics Sub-Laboratory, Laboratory of Agricultural Energy and Machinery, Department of Agriculture and Biosystem Engineering, Faculty of Agricultural Technology, Universitas Gadjah Mada, Yogyakarta. This is hardware used for non-destructive measurement. They are DSLR camera Canon EOS 700D, camera stabilizer, and laptop. And then, this is hardware used for destructive measurement. They are box container, measuring cup, and dropper. This is hardware used for growth processing. They are LED growth light, electric socket timer digital, and growth chamber. And then, this is software used for data processing. They are 3DF Z5 Pro version 4.523, SketchUp 2017, and Photomodeler Scanner version 2020. The materials used for this research are Chinese cabbage with 4 different ages, 14, 21, 28, and 35 days after transplant. Chinese cabbage seeds and growing media. This is research procedure for this project. This is the algorithm for 3D reconstruction and volume estimation. There are 5 main steps of 3D reconstruction: plan image acquisition, image matching, 3D model of plan, volumetric measurement of model, and validation. Camera calibration. Calibration is the process of checking and setting the accuracy of a tool that will be used to get precise results. An important calibration step is carried out to obtain the interior orientation parameter of the DSLR camera used in this study. Plan volume data will be evaluated using several data analysis methods. There are coefficient determination, root mean square error, and mean absolute percentage error.
Okay, let's continue to result and discussion. Camera calibration is done by taking 12 photos of the calibration grid from various sites and the retrieval technique. The interior orientation parameter is generated from the process of calibration for DSLR cameras. From the calibration result in the table above, all photo data are well calibrated with an RMS error value of 0.103 pixel, and this result indicate that DSLR cameras can be declared good use in this photogrammetry method because the resulting error is not more than 1. The result of the reconstruction are visualized in the form of sparse reconstruction, dense reconstruction, and mass reconstruction. And this is visualization of the reconstruction result in the form of animated videos. This result of the 3D reconstruction can represent the original plane objects from the shape to the texture of the object. Actual and estimated volume are used to develop a calibration model for volume variation. This result of reading the volume value of the software show difference with the original volume. The calibration test result of each sample are indicated by R-squared value, and this figure shows the result of linear regression test of the samples. The highest R-squared value is sample 1 with the value of R-squared of 0.9991 with regression formula can be written y equals to 3078x plus 12.25. The calibrated model will be evaluated to estimate the volume of other plane samples from validation and performance testing. The volume generated from the software after the conversion process show no significant value when compared to actual volume. The volume value obtained after the conversion process will then be analyzed. So from the calculation, we obtain the value with R-squared value 0.9991, root mean square error 26.08 cm cubic, and mean absolute percentage error 10.43%. So the close-range photogrammetry method was applied to monitoring the volume increase of Chinese cabbage. And this is conclusion of this study. First, 3D reconstruction system with close-range photogrammetry method can be used for modeling planes into 3D objects that is sufficient to represent the original object. Second, from the test result of plane volume measurement, the accuracy of the volume measurement is quite good. And third, the close-range photogrammetry method can be applied to predict the volume increase of planes. Thank you for your attention.